Alright, welcome back guys. So in today's video we have another question from chapter 5, and we have this question that we need to determine the reactions at the supports at point A and B. So we have a roller at point A and a pin at point B. Before we start, please make sure to subscribe to the channel and share this content with your friend. It's going to help me to grow the channel and reach out to more students. So let's start with the free body diagram. So we have this rod AB that we have the pin at point B, which means we have two unknowns for BX and BY. We have the roller at point A. Let's consider our X and Y like this for positive side of X and Y, and at point A, since it's a roller, we only have a normal force. Let's call it NA. And we have this distributed load that is applying at AB. So for finding that, since it's a symmetrical load, we know that it will be applied at the center of this beam right here. So we have 400 Newton meter. So if you want to find the load, we have two right triangles on left and right, and if we want to find the area of the left one, we have 400 times the base, which is 3 divided by 2, and same for the right triangle. So this will be the load, and since it's symmetrical, again it will be applied exactly at the center of this beam. The other information is the angle of NA, and since we know this part, the right triangle in here, we have information in the question. So if you want to apply that into the other, on the normal force, then we know we're 4, 3, and the hypotenuse is 5. And if you want to figure out how to find these two, so we know that these two angles that I'm showing in red are the same, this one and this one. And that's because when we have two angles that each side of them are perpendicular to each other, those two angles are the same, this one here and this one. So this side will be perpendicular to this side and the other one to this one. There's a video in the channel that can find these tricks on how to find the angles. I'm going to put the link in the description below. And now that we have all the forces and angles in the question, we are good to go to equilibrium equations. If we look at this, we'll see that we have the most unknowns at point B, BX and BY, which means if we start with the moment about point B, the only unknown that's left is the normal force at point A. So let's consider counterclockwise positive for the moment, and for that we have the moment of the distributed load, which is applying at the middle of this bar, and we know the magnitude will be 400 times 3 divided by 2 times 2, which at the end will be 600 plus 600 or 1200. And since it's a counterclockwise moment, it will be positive. So we have force times the perpendicular distance, which is 3 meters here. And also that's the first part. And the second part is the moment of the NA. And if we look at the NA, we'll see that the X component of NA won't make any moment. I'm going to show it in red. So this will be our X component, this is our Y. So we'll see only the Y component is making a moment, and it will be clockwise, so there's a negative sign in here, and the distance will be 3 plus 3, so we have NA times 3 plus 3. Oh, so we have NA times 4 divided by 5 times 3 plus 3. And from here we can find NA, which will be 750 Newton. And we found the first reaction at point A. There's two more left, BX and BY. And if you do the moment about point A, we can cancel out the moment, the BX, so we'll end up having BY as the only unknown, and we can find BY. So same thing, this time we have the moment of the distributed load, and since it's counterclockwise, this time it will be negative. So we have negative 1200 times distance, which is 3, and we have the moment of BY, and the distance will be 3 plus 3, which is 6. And from here we can find by as the other unknown, and if we do that we'll find by 600 Newton. So there is one more unknown left, which is bx, and if we look at this, if we do fx, the sum of all forces in x direction, we can find the last unknown. We only have the x component of NA, which will be NA times, this time 3 divided by 5. And we have bx in the negative direction equals 0. And we know NA is 750 Newton. So we can find bx as the last unknown in here. So we'll get 450 Newton for bx. Please make sure to subscribe to the channel. It's going to help to grow this channel. And you guys have a good one. I'll see you in the next one.